Alright, we're on the second page of the A3 notes, so we're going to look at some special cases with inequalities involving absolute value and a couple of examples writing expressions with absolute value inequalities. So these number 3, we're going to look at these examples here. So let's look at what this says. It's absolute value of 6x minus 9 is greater than negative 2. So if we look back at our cases, you might be tempted to say, well, let's use this case and say, well, that expression is less than negative 2 and greater than 2 or something like that. But problem is, remember, these cases only really work if k is greater than 0. And so if we have a negative number, especially if we have a negative number here, well, what's the problem? Can an absolute value ever be, is absolute value bigger than negative? It's always bigger than negative, right? Absolute value at most can be 0 because absolute value represents a distance, and we can't have a distance less than 0. And distance is always going to be greater than a negative, right? The minimum can be a 0. So if there is a negative here, you just got to do a little bit of thinking, and they're actually easier. So you ask yourself, if this is negative, when will absolute value be bigger than a negative? It will always be bigger than a negative. The smallest it could be is 0. So there's really no work to show here. Once you've recognized that this is negative, you can stop and say, this always works. So it's all real numbers, right? All real numbers will work. And you could try any real number you like in here. When you take the absolute value, if it ends up being negative, it will turn into a positive. So in interval notation, the way we write all real numbers is everything from negative infinity to infinity. Okay? So this would be our answer here. Without any work required other than a little thinking in your head, what does the negative do? Absolute value is always greater than a negative. So look at the next one. We have absolute value is less than or equal to negative 5. Well, can absolute value ever be less than a negative? No. Can it ever be equal to a negative? No. So this is an example where it's never going to happen. Again, we don't want to use those cases. We don't want to do any algebra. We need to be on the lookout for these negative numbers. If we get a negative number over here, we can't use those cases from the last video. We have to just use a little bit of thinking. And since this is never possible, absolute value of anything can never be less than a negative or equal to a negative. So there are no solutions here, right? No real solutions. And there's a symbol I believe is available on your My Math Lab pad. It's the empty set. It's a circle with a slash through it. That means no real solutions. Okay? One other example is not on the notes printed here, but I want to give you an example. What if we had an equation? Let's say we had something like 7x minus 3 equals negative 5. And we have this absolute value around 7x minus 3. Is that ever possible? Can absolute value ever equal a negative? And the answer is no, right? So this would be another one where we have the empty set for a solution. So be on the lookout for those negatives. And if you start to do any algebra here, you might arrive at a solution, but the solution would be incorrect. Always check to make sure absolute value is set either with equal, less than, or greater than with a positive before you start doing any algebraic manipulation. Because if this number over here is a negative, you just have to do a little bit of thinking and realize absolute value can never be negative, which leads us to these results here. Alright, so let's look at the last thing we have to do, and we're asked to write expressions for each of these using absolute value. So this one says m is no more than 9 units from 3. So if we look at how far m is from 3, an expression for the distance between m and 3 is m minus 3. Kind of, because we don't know which side of 3 m is actually on, do we? So if m were on the smaller side of 3, we would do 3 minus m. But the way to take care of that is to do absolute value. The distance between m and 3 can be written as the absolute value of m minus 3. If that's no more than 9 units, that means it's either 9 units or less, right? So this expression is less than or equal to 9. And we could solve that if we wanted to, but that's all we're asked to do here is to write the expression. What this tells us is the absolute value of m minus 3 is the distance between m and 3. And this tells us that it's no more than 9 units. It's less than 9 units, or it's equal to 9 units, which is the same as no more. The next one I think is pretty similar. T is within 0.02 units of 5.8. So we're looking at the distance between t and 5.8. We could write that distance as t minus 5.8. Or absolute value, right? Absolute value of that difference is the distance between those two. And we're told it's within 0.02 units, right? So that means it's less than 0.02 units, right? And within, does that include 0.02? If it's within 0.02, I think that would include. Within is kind of the same as no more than. So I think we could write that one in the same kind of way. Now, you could have a greater than involved in one of these two if this said no less than 9 units instead. Or if it said at least 9 units from 3, we would have greater than or equal to 9. Or if it said greater than 9 units from 3, we just have a greater than. So you'll run into some examples. I think there'll be 1 or 2 like that in my lab. And hopefully you have some success with those. But we're all done with A3. We have one more section in this chapter, and I think there are a couple videos for that. So we'll move on to that.